Okay, good morning. It's Thursday. There's your joke of the day. I can't put it on a cheesy scale, but it is pretty cheesy. Okay, today we're going to finish the organic reactions, give you the notes for those. Then we'll go over the homework. I'm going to make a separate video altogether for reviewing the functional groups. And your test is going to be due tomorrow. There's no homework other than studying and doing your test. Yesterday I said that there would be a Google Meet today at 1 o'clock, but I'm going to have to move it to 2:15. So hopefully I'll see you then. Okay. Yesterday we learned about organic reactions. Organic reactions are basically what are going to happen between organic compounds of different sorts. Essentially, they're going to be a little bit slower reactions than anything that's ionic because there are more bonds to break, essentially, and form. The first one we looked at was combustion, also known as burning or oxidation. Combustion, you need oxygen if it's going to be complete, and usually high temperatures. If you don't have enough oxygen, then you end up with incomplete combustion. Incomplete combustion, you end up with carbon monoxide, which is kind of dangerous, and water. Regular combustion, you're going to have carbon dioxide and water. Okay, so these are the products that you're looking for to figure out if it's a combustion reaction. A substitution, you should think of the word substitute. In order to substitute for something, there has to be something in place already. So a substitute teacher comes in and takes the place of the teacher who is there. So substitution, you've got to have something that is completely saturated. Okay, in this case, saturated with hydrogens. So a substitution reaction is one in which you start with an alkane and then you add either a functional group or bromine or chlorine usually. And then they get substituted for, the hydrogens get substituted for the chlorine and bromine. An addition reaction, you're adding something. And just think of the word. So addition means there's room somewhere in order to add it. So in order for an addition reaction to occur, there has to be either a double or a triple bond. Okay, so that's what's happening here. I break this double bond, and then I add bromine to the ethene molecule in order to have the bromines attach. Okay, so that's an addition reaction. There are other types of addition reaction like hydrogenation. I'm adding hydrogen. We talked about margarine with that. And then hydrohalogenation is the addition of both of them. And lastly, we finish with polymerization. Just remember that poly means many, and we're making a molecule that is very large. Okay, and I gave you a lot of different examples here with different kinds of plastics, synthetic and man-made rubber. Actually, nature has a lot of different polymers too. Cotton is a polymer, protein is a polymer, wool. Okay, so essentially we're taking smaller molecules and then making big long chains of them. All right, and then we had some examples here. And one more specific type of polymerization is condensation. If you think of condensation as the formation of water, like water goes from a gas into a liquid by condensation, that means that the water is going to be left over. So that's the characteristic of a condensation reaction. In biology, you learn dehydration synthesis. It's essentially a condensation reaction because water is taken out. Okay? So essentially, here's what we have. Condensation reaction would be one in making proteins that I just mentioned. So we're taking amino acids. Remember, amino acids have the amine group and an acid group. And then they have something different for each one of them. But when they come together, we end up having what's called a peptide linkage, and then the hydrogen and the OH come together to form water over there. Okay? And I just mentioned the natural polymers. Today we'll look at the last three. Fermentation is one of them. Fermentation is the breakdown of sugar by enzymes to produce, and these are the end products here, alcohol and carbon dioxide. So this is a naturally occurring thing that's made, that's done by yeast and certain bacteria. So the process is used to make alcoholic beverages such as wine and beer, and in the baking industry. Okay? Bread would not rise without the carbon dioxide. So when you look at bread a little bit more carefully, you'll see that there are pockets all the way through it. And those pockets are because of the carbon dioxide gas bubbles that are there. All right? Forming little pockets. Bread and cakes. Okay, so this happens in yeast and bacteria. You know, Swiss cheese has the holes in it. It's because the bacteria that ferment the milk into cheese produce a lot of carbon dioxide, and it gets trapped in there, and then you get these big holes where the gas was. Okay, so this is a recap essentially from biology. You start with glucose, and then you end up with ethanol and carbon dioxide. Here's the overall reaction. This is an anaerobic respiration. Anaerobic means there's no oxygen available. So these things, fermentation is going to happen without oxygen. So glucose and yeast, you end up getting alcohol, carbon dioxide. Fermentation, again, is an energy making. Remember, we don't make energy, but we convert it. But it doesn't get much. If you remember from biology, it only produces 2 ATP. It's not very efficient at all. Aerobic respiration is much more efficient. Products, in this case, are water and carbon dioxide, and you get 18 times as many ATP little energy packets. Humans and other complex organisms use aerobic, and as you probably can remember, it's essentially the opposite of photosynthesis. All right, the next type is called esterification. Esterification, we're making esters. So that's an easy one to remember because esterification has ester in it, so it's making esters. And what are we making them from? Well, can you recognize this? This group here, C double bonded O and then OH, that's an acid. And then it's combined with an alcohol. So in this case, can you name this? 2 is eth, right? And then I put oic, ethanoic acid. And this is 1, 2, 3, that's prop. And then this is a hydroxyl group, so this is an alcohol, OL. And I have to name what number it's on, it's 1-propanol. So if we add ethanoic acid and 1-propanol, water comes out, as you can see by this. Okay, so this is a condensation reaction, essentially. And look what we have here. We have a C double bonded OO. And that is an ester. She cool? Ester's cool. Okay, how do I name this? Just to remind you, when I'm naming esters, I look at the oxygen by itself, and I look at the group that's attached to it, and that one comes first. So this is propyl, because it's 3. And how many do I have over here? 1, 2, and that's, there's a dash here, sorry. Ethane, and then in esters I end with an O8. So that's propylethanoate. Okay? So, just to cap it up, esterification is the making of esters from acids and alcohols. All right? Second to last one here is saponification. And that's not that hard to remember because these four letters make soap. Okay? Saponification is the formation of soap. Okay? How do we make it? From an ester, and we have to have it in the presence of a base. This is the reverse of esterification. Okay? So we end up with, in esterification, we end up with an ester. So if we take the ester and add water back to it, we end up getting, here's the ester. If I add the water back to it, I end up getting an acid, like ethanoic acid, and alcohol, propanol. All right? So let's look. So, can you recognize this as, whoops, didn't want to do that. Can you recognize that as an ester, C double bonded O? Now, this is called a triglyceride, which is actually a type of fat. This was commonly known as lye. So in old-fashioned days, they would take fat from an animal, a pig or a cow, and they would mix it with lye, which is sodium hydroxide, which you actually could make that pretty easily from ashes from a fire. And then glycerol is made, and then soap. So that's how you make soap. You take fat and add acid to it, or excuse me, a strong base, like potassium hydroxide or sodium hydroxide, and you end up getting soap. Soap dissolves in both water and grease since it has both a polar and a non-polar end. So saponification is making of soap, and essentially you're taking an ester and adding a strong base to it. Okay, last little chunk here. Primary alcohols are oxidized to aldehydes, and those are oxidized into acids. Remember, primary alcohols are those that are attached, that the carbon that's attached to the hydroxyl group is only attached to one other. Okay, so you can see what's going to happen here. This gets turned into an aldehyde. I'll leave this part out. Whoops, I'll leave that part out. Remember, an aldehyde looks like this. There's the rest of it. And then these get oxidized into acids by adding that oxygen. Secondary alcohols are oxidized to ketones. So if I've got a secondary alcohol like this one, that means that the oxygen, the hydroxyl group, is attached to a carbon that's attached to two others. And you might be able to see that this is going to get converted into a ketone, which looks like this. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so there's your ketone. All right? This is not hit very hard at all, by the way. Okay, the last one is cracking. Cracking is the process where we take large molecules and break them down. All right? The source for these, the cracking process, is petroleum. Okay? Petroleum. So, essentially, you take a long hydrocarbon and crack it, break it into smaller pieces. And that's what happens when you take petroleum, start to break it down in a giant vat, essentially, under a lot of heat. And what happens is you end up with smaller pieces. And then these pieces can be used for other processes like ethene, which is the same thing as ethylene. This thing can go through polymerization, so I can make a polyethylene with that. Okay? So these are the types of things that help make paints and plastics and certain medications. All right, so that's the end of the organic reactions and therefore the end of all the notes for the organic compound unit, organic chemistry unit. All right, so let's look. All right, we're going to go over the homework and then I'm going to make a separate video for review. So it's 208 and I wanted you to do the odds. All right, let me blow this up a little bit. Some of these are challenging. Which type of reaction do ethane molecules and ethene molecules undergo when they react with chlorine? Now remember, ethane only has single bonds, whereas ethene has a double bond. So I have to substitute, excuse me, I have to substitute here because it's saturated with hydrogens. Here I can add because I can break that double bond. So they don't both react with addition. And they don't both react with substitution. Ethane reacts with substitution. I can substitute a chlorine here, kick that hydrogen out and put a chlorine in its spot. And ethene reacts by addition. I can add a chlorine here. So this is my answer. And the opposite is not true. Okay? So think about how they are structured, and that's how we'll do these two. Number 51 is the next one. Which substance is made up of monomers? Mono means one. Joined together in long chains. Well, you might have to go into your notes for this, but esters, ketones, and acids are not long chains, really. They can be long, but they're not chains, which means that they're the same thing again and again. It's a protein, and proteins are made of amino acid chains. Okay? So that is, each amino acid is a monomer to make a polymer. 53. 53. Two types of organic reactions are, okay, at least we can recognize them. Decomposition, nope. Evaporation, definitely not. Evaporation is a physical process. Esterification and polymerization, that's the answer. Addition is one, but sublimation is a physical process going from solid to gas, so that one's out. And deposition is going the opposite way, going from a gas to the formation of a solid, like in the formation of frost. And saponification, we just learned about, that's the making of soap. 55, the reaction represented by this. Okay, for me, I've got to draw this. So here's CH3, then here's CH, and then CH2. I almost drew the H, CH2, so I can only have 2 on this thing. So, since each carbon has to have 4 bonds around it, there has to be a double bond right there. So now this one has 1, 2, 3, 4, and this one has 1, 2, 3, 4. Okay, so this is propene. Okay, so since I have a double bond there, I can add to it. So this is an addition. Fermentation ends up with alcohol. This is alcohol and carbon dioxide as end products. Substitution, I'm going to have an alkane, so that one's out. And saponification, I'm not making soap here. There's no ester at the end. All right, next one is 209. Let's Let's make this a little bit bigger. $57. How about an addition reaction? So in this case, I've got to do the same thing. So you could look up each one of these. I know that methane is CH4, so since it's saturated, it can't be an addition. It must be some sort of, it could be a substitution. But then I'm looking at the end products. Look, I've got carbon dioxide and water here. That's a combustion reaction. This one's combustion. C2H6. C2H6. 1, 2, 3, 4, 5, 6. Okay, so this is an alkane, yes? Alkanes cannot be added to. They have to be substituted for. So this one is out. C3H6. 1, 2, 3. I can only have 6 hydrogens on here. So I can draw it different ways, but I know that this is going to be a double bond. And you would have to fiddle with it, but I'm not going to take the time for it. So 1, 2, 3, 4, 5, 6. So here's my C3H6. This is a double bond. Because it's a double bond, I can add to this. So this is my answer. C4H10, well, I know that that's C to the N, H to the 2N plus 2. That's an alkane. This one is butane. Again, I cannot add to something that's completely saturated, so that one's out. All right, 59. This equation, I'm adding 2 alcohols to make a ketone. So, these are all alcohols. And what's happening here? I'm making a ketone. If you don't recognize that, you can look up an example of a ketone, but that's your answer right there. Okay, this is not an acid. It would be COOH for an acid. It's not a polymer because it's not very long. It's only 2 carbons. And it's not, oh wait, I think I did that wrong. I think it's 4, my fault, because it's dehydrating the alcohol. My error. We're not oxidizing any of the way. I should have caught that. That's not a ketone, that's actually an ether. So let's look. Caught myself there. All right? So, when you see this, you'll see that the ether, that's going to be shown just like that one was, my fault. And then a ketone is going to show a double bond there. All right? All right, sorry. Number 59 was 4. Back up to the top. 63. Which reaction results in the production of ethanol? Ethanol is an alcohol, and you just have to run through your notes. Combustion results in carbon dioxide and water. Esterification would be making an ester. Fermentation is the answer, and polymerization is not how you make ethanol and alcohol. You'd be making something like polyester, something like that sort. 65. 2 types of organic reactions. This is just identifying again. This is one, and this is one. This is actually the answer then. Fermentation is one. Transmutation we haven't learned about. That's nuclear. Deposition is not one. That's a physical thing. Synthesis is too general, so we can't accept that one. And deposition is also a physical process. And lastly, at the end, I wanted you to do all of those. Let's get rid of this. Okay. So, write the number of the organic reaction chosen from the list that will produce these substances. Okay, so ethanol is made from the process of fermentation. So this is 4. Glycerol is something that is made through esterification. From saponification. Let's go back in the notes to check that. Here's saponification, the making of soap. Glycerol is actually one of the end products of that. And again, you would have to look that one up. Which is okay. So that is saponification. And OA is an ester. That's how we name esters. So that's esterification. Poly is the product of polymerization. So that's 3. And dichloromethane, well, if it's dichloromethane, it's either going to be a substitution or an addition. In this case, I don't have an addition as one of my choices, so it's got to be 5. Okay? All right. Google Meet today at 2:15. I changed that and I'll also post it. Your test is due tomorrow at 3:15, by 3:15. And if you have any other questions other than this, then you're welcome to let me know. Okay, I'm going to make a separate video about naming, just practice naming functional groups.